Welcome to today's webinar brought to you by pgEdge. I'm Stephen Faig, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Rapid Deployment of Globally Distributed PostgreSQL for Low Latency and Unbeatable Availability. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we're excited to have with us Philip Merrick, co-founder and CEO of pgEdge, and Curtis Mizey, Head of Cloud Engineering at pgEdge. Now I'm going to pass the event over to Philip to get us started. Welcome to the broadcast, Philip.
Thank you so much, Stephen, and thank you everyone for joining us. So if you have joined today, I'd say it's a reasonable expectation that you are somehow involved in the development and running of applications that have to be always on, always available, and always responsive. And sometimes always responsive regardless of where in the world the end user might actually be coming from. And so what we're going to talk about today are how you actually deliver on this. How do you make your applications always on, always available, always responsive with some level of assurance that that's always going to be so? Let's break that down a little bit. So your application end users can be and are often globally distributed, maybe just across the continent on multiple coasts. Maybe if you've got an internet application, you've got users coming literally from all over the world. And even if you've got an internal corporate application, odds are pretty good that those folks are distributed as well. So your users can be distributed, but your applications mostly are not. Your applications might be in the cloud, but typically, almost always, they're going to be deployed in a single cloud region. And they're kind of tied to that one region. Not too many applications are actually architected to be multi-region. Well, why is that? Well, the root cause is it's because the databases that these applications are so dependent on are hard to globally distribute. It's hard to have a database running in multiple regions, particularly if it's a relational database. So that's the problem that we solve at pgEdge, making it possible to globally distribute Postgres databases around the network. Now, the fact that you cannot easily distribute databases today leads to some very, very significant pain. So fundamentally, it amounts to poor customer experiences and lost revenue. On the one hand, the high latency that your remote users are going to see manifested in the form of slow page load times, that in and of itself creates a very poor customer experience. If you're running an e-commerce application, it's pretty well known in the e-commerce industry that each half second or so of delayed response in drawing a page results in a quantifiable amount of lost sales. And there have been various studies on that over the years. If you've got a SaaS application, if you've got users in Europe or Asia, or even just on the other side of the country, who are consistently seeing poor response times, that's going to show up in poor customer sat and ultimately maybe customer churn. But then, maybe even more fundamentally and more important, what happens when a single cloud region goes down? So you're deployed in one particular cloud region, maybe it's Amazon US East 1, popular choice, or another. What happens when that cloud region goes down? So many many applications are just not architected to deal with that. And so when you have that outage in that single cloud region, your application takes the outage as well. And so if you're single cloud region architected, this means that you aren't actually able to deliver on SLAs at the 4 nines level. Also, and related, with Postgres in particular, it's difficult to perform maintenance activities such as software upgrades without taking some scheduled downtime. And of course, that makes it hard to be 4 nines also. So, you don't have to take my word for it. I mentioned, there's various research out there about what happens if you're in the e-commerce or related businesses and you've got very slow page load times. It is going to cost you money. And we do know that when a single cloud region like Amazon US East 1, or last year we saw a big outage with Google Cloud's main France region, main Western European region, we know that causes a lot of outages with a lot of applications, a lot of popular applications. So what we want to talk about is how we make sure that it's not one of your applications. Alongside all of this, some of you may already be using Postgres in your organizations, but not everyone's aware of the extent to which Postgres has become, among developers, the most popular database. Not just the most popular relational database or the most popular open source database, but the most popular database. The Stack Overflow Developer Survey, which each year goes out and surveys thousands of developers, last year, for the first time, placed Postgres at the top of the list of most desired database technology to work with. DB Engines, that looks at a range of different data sources, made Postgres the DBMS of the year last year for the 4th year. But importantly for this discussion, despite having been around for 25 plus years, absent pgEdge, there is no open and supported distributed Postgres. No distributed solution for Postgres existed before pgEdge came along. That was both open and commercially supported. When we say open, we mean that the source code is available on a reasonable community open source license. So if you think about in other database technology areas, some of the big legacy databases like Oracle have had a distributed capability with things like Golden Gate for many years. And more recently, we saw NoSQL databases come to market with distributed architectures from the get-go. But Postgres itself has been missing this, and that's what we here at pgEdge are here to fix. And so we talk about our pgEdge fully distributed Postgres being optimized for the network edge. What we mean by that is you can literally get copies of your database closer to where your users are connecting to the network. So in multiple regions or multiple data centers around the global network. And these copies can take both reads and writes, both read traffic and write traffic at pgEdge nodes. But it's not just about the network edge and edge-oriented architectures, such as things based on platforms like Cloudflare Workers, but we also find that our customers are using pgEdge to go multi-region and even to go multi-cloud within the same application, or hybrid cloud, providing replication between on-premise installations and the cloud itself. And then perhaps pretty excitingly, it's 2024 and I've got 10 minutes into a presentation without talking about AI, but we do see a number of our customers deploying pgEdge to support AI inference at the edge. One customer in particular with major customers in Japan, they had those customers in Japan seeing 7-second page load times, response times, and that just wasn't acceptable. And so they're now moving to doing their AI inference at the edge in their application. Combined with the PG Vector Postgres extension, pgEdge is a great solution for that. I mentioned that we are fully open, but we are also fully Postgres based. So there are other distributed databases that are Postgres compatible, which only takes you so far. pgEdge starts off of the Postgres code base, and we provide our functionality through a standard extension to Postgres. So the benefits are low latency, replicated databases near end users, architecting for high availability, and DR, disaster recovery, and failover between regions are effectively built in. If one region goes down, traffic is automatically routed to the surviving regions, and so it's not so much a failover as it is having a fault-tolerant architecture. And then I briefly mentioned Cloudflare Workers and the edge. Some of you have maybe experimented with application architectures that take advantage of platforms like Vercel and Cloudflare Workers, where you get to deploy your application logic around the global network. Now you can have your database close to where that application logic is running as well. And Curtis, in a few moments, will give us a little bit of a demo of that. And so we are announcing what we call pgEdge Cloud Developer Edition, which is a great entry point into exposing your developers to pgEdge and its capabilities. You can literally get up and going with a distributed Postgres cluster in 90 seconds or less, which seems like an extraordinary claim, but hopefully Curtis is going to prove me correct on that as well. So pgEdge Cloud Developer Edition is serverless, fully distributed Postgres, taking reads and writes at every database node. The underlying technology works via asynchronous logical replication with conflict resolution. And the fact that it's serverless means you don't have to worry about provisioning the infrastructure. We're managing that. Although you can, in the enterprise edition of pgEdge Cloud, take full control for where you deploy the clusters, what regions they span, and those can actually be in your own cloud accounts under your control. Developer Edition is very fast to get started with. I made that 90 seconds claim already. We provide you with pre-built clusters spanning regions across North America, Europe, and Asia. And we have all the code that you need to be able to connect applications and all the connect strings and all of that good stuff is right there. And we have today integration already available for Cloudflare Workers, and Vercel and Fastly are coming soon. And one of the other edge-friendly things we do, which also helps provide for that failover, is we've built in latency-based routing. So with just one actual connection, you can, through DNS, automatically connect to the nearest available node that is up and running. And so with that, I'm going to turn things over to my colleague, Curtis, who is actually going to show you pgEdge Cloud in action.
Thank you, Philip. Yeah, let's jump right in. Thank you, everybody, for being here. I will share my screen if you just give me a moment. All right, you should be seeing my browser window, and I will get right into this. Yeah, so thanks again, Philip, for all that intro. In my demo section here, kind of the agenda for this is we'll spin up a global database. We're going to start replication on that and run some test queries so you can start to see a globally distributed Postgres in action. Then we'll also take a look at this Northwind Traders demo application, which is running on Cloudflare workers. We'll talk a bit about how that was built, use it as a reference when talking about low latency routing and practical solutions for high availability in Postgres. So let's dive right in. You should be seeing the pgEdge Cloud UI. And here you're basically prompted to create your first database. We'll adjust our database name, and then there's one primary choice you have to make at this point, which is where you want your database nodes to be located. 3 options come out of the box right now: US and Europe, US only, and a fully global cluster. We're just going to go with US and Europe for now to get a sense of how this works. And we're also going to opt into this Northwind Traders data set so that we have some example data to work with. This basically has some tables with orders, products, and things like that built in. And again, this is actually what you can get today if you sign up for pgEdge Cloud for free. So we're going to go ahead and click Create Database. What pgEdge is doing now is spinning up a Postgres service at each of the 3 locations in that cluster. We set up private networking and logical replication between all those locations, and we create a unique domain name for each node. And that gives any Postgres client the ability to connect to a specific node or to the cluster. And if you connect to the cluster name, you get that latency-based routing that Philip mentioned before. A little bit about node names in pgEdge. When this comes up, you'll see nodes for N1, N2, and N3. So you'll see metrics and other information for those. Let's see here. Let's see. Give this another second to come up, or I will switch to a different view. Let's see. While we're okay, here we go. All right, I think I hit the 90-second mark. Or was under it, I mean. All righty, here we go. So we've got a database running spanning US and Europe. The Northwind Traders data set is loaded here. So we've got 14 tables in place that are ready to replicate. This is kind of a default configuration that comes up when you spin up this pgEdge cluster with this data set. All these tables are loaded on N1. I'm going to go ahead and start replication on those. This copies the table schemas to N2 and N3, and then uses the pgEdge extension behind the hood, which is called Spock, to set up replication across all 3 locations. There's some other information here in the dashboard we can talk briefly about. You get an overview of what database users exist in the system, and information here on all the connection strings we can use. We'll kind of circle back to that in a little bit. All right, so here you can see that those 14 tables in our data set are replicating now. And we can actually drill into those here in the UI to see their contents too if we wanted. Right now, what we're going to do is connect to the database using pSQL, the standard Postgres client. And then we're going to run queries on that so you can see replication in action. So what I'm going to do now, if you give me a second, is pull up a terminal window, and I will switch to that. All right, hopefully you see my terminal. Let me know if that's not the case. I've got 2 panes here. So what I'm going to do is connect 2 clients, actually, one to N1 and one to N2. And that will let us confirm replications in action. I'm going to copy a connection string from the UI, copy the second one. All right. So if we look at the domain names here, you can tell that I am connected to two different places. So IAD is the airport code for Dulles. That's near me. PDT, airport code out in Oregon. So we're connected to two different nodes here. If we look at the tables, we got the same set of tables on each. We can drill into one of the tables, the categories table, take a look at what's there. So here you can see we've got 8 records in that table, some different food categories we're working with here. And the same data on all the nodes at this point, which is great. At this point, we will go ahead and do a insert query on either one of the nodes. I'll run it down here on N2. We're going to insert a new category of snacks into the categories table. And querying again, you can see that we went from 8 records to 9. So now there's a snacks record in there too. And on N1, we have the same information. So, in a lot of ways, this is a very basic example, but important. So we started replication in the UI, and now any change we make to any of the tables on any of the nodes gets replicated to all the other ones automatically. I'm going to pause here and switch back to the web page view. All right, hopefully back on the pgEdge Cloud dashboard. One thing I'll call out here in the metrics, we can see that when we wrote to the N2 node, there was replication output from that to the other nodes in the cluster. So that's what this little spike indicates here. So we can tell that I actually did the right thing and that the change was replicated across the cluster. All right. In normal applications, you would use this nearest node functionality to take advantage of that latency-based routing. The key is this domain name mentioned here will actually resolve to the nearest IP address of the nearest node automatically. And that actually handles failover. And that, say we're connected to N1 normally, and that node goes down, this domain name will automatically resolve to one of the other nodes in the cluster at that point. So that way, without any extra logic or sophistication at the client, you'll get a higher availability application or architecture. All right, so a couple other quick things to call out here in the UI. You can drill down into the tables and see what is in there. So we can see our ID 9 entry there for snacks. You can confirm the data is on the nodes as you'd expect. And then regarding integrations, this is kind of a launch point for us to start talking about Cloudflare Workers a little bit, and then this Northwind Traders example app we have. So if you did want to give this a try with Cloudflare Workers or another app, there's various walkthroughs in both our documentation and the app that guide you through how to do that. I'm going to just switch tabs, and hopefully you see the Northwind Traders app now. Philip, you can let me know if that's not the case. So you should see Northwind Traders dashboard. What this is an open source application that pgEdge created. And this is open source on GitHub. You can take a look at the source code at github.com pgEdge-Northwind. You can see both the Cloudflare worker code and some of the database set up to do this. And this is just a handy app where we can see how this latency-based routing works in the real world. So say this is an e-commerce application. This is kind of how this would all play out in practice for clients connecting around the world. We've got a 3-node cluster again with Oregon, Eastern US, and Germany. Each blue circle on here is a user connecting to this web page and where they're connecting from. So using Cloudflare workers, you can actually capture the latitude, longitude of where people are connecting from. We then draw lines from where that user is to the database node that they're using when accessing the application. And we also show here's a better example, what Cloudflare data center this request is routed through. So we've got a couple of these users near LA routed to the Cloudflare data center in LA, and then to the West Coast pgEdge node. So you can see this kind of play out across the globe. And you can imagine for these users in Europe, for example, this person accessing the application here is going to see a vastly more performant application than they would if the database was only located, say, in the United States. Traffic like that could easily be delayed 100 milliseconds, 200 milliseconds or more per request. And when that adds up in an application across dozens of requests, it can make a big difference. So this web application we'd expect to be vastly more performant than kind of a run-of-the-mill single database setup that you might see today. Just to call out a couple other interesting aspects of this. So you get a measurement here of the exact latency from the client to the Cloudflare data center that's closest to you. And then from Cloudflare to pgEdge, you can see the latency there as well. So you can actually access this application too from your browser right now if you want, northwind.pgedge.com. And you can kind of play around with this. You should see yourself on the map when you load it, and you can get a sense for what the latencies might be for this case. And as you navigate through this application, it's making queries through Cloudflare workers to the database. And then if you come back to the dashboard, you can actually see a lot of that information, exactly what the queries were that ran and how long they took. So we think this is a really nice way to see pgEdge in action. While this is with Cloudflare workers, you could, take advantage of the same database architecture from any other application, whether it's in AWS, Azure, Google, etc., or anything else. All the same principles apply, especially when you're able to run compute at two different locations too. Ideally, your compute would be located in the same places that your pgEdge database nodes are. All right, so yeah, hopefully that gives you a lot of the idea here. Again, you can give a lot of these things a try yourself since they are open source. Northwind.pgedge.com for this. We are github.com/pgedge there. We have examples with Cloudflare workers. We have example ways to run pgEdge in Docker, and a whole lot of other ways to kind of try us out for free and get started. And one of the other things in the web application that we won't show today, but we can chat with you about, is actually provisioning your own pgEdge clusters in whatever data center regions you have and are important to you. We showed a 3-node cluster, but you can go higher than that. So there's a lot of different ways you can kind of configure this to meet what you're trying to do with your application. All right. I think that is most of what I was going to cover. So back over to you, Philip.
Terrific. Thanks so much, Curtis. So just to sum up, we've given you a little bit of a taste today of how pgEdge distributed Postgres can make it possible for your applications to be fully globally distributed for low latency for your users, regardless of where they're connecting from, and for ultra high availability, providing built-in failover disaster recovery between regions, and thus building in resiliency against possible cloud and other outages. What we would love is for you or your developers to actually go take pgEdge Cloud Developer Edition for a spin. As we mentioned, it is actually free. we provide a free tier up to 12 gigabytes across your cluster. And as Curtis demonstrated, you really can get up and going very quickly. We do have a bit of a giveaway going on in conjunction with this webinar. The first 500 signups receive one of these free t-shirts, which we think are pretty awesome. Stephen also thinks it's pretty awesome. And we mentioned a little bit of AI here in this webinar today, talking about AI inference at the edge. The other place we can talk about AI is we did use a little bit of generative AI to generate the cool Postgres elephant on the motorbike on this t-shirt. So again, it's pgEdge for fully distributed Postgres, completely open, completely based on Postgres for low latency and high availability. And with that, thanks for your time and attention. And now we can go to some Q&A. Stephen.
Thank you very much, Philip, and thank you, Curtis, as well. I do love that T-shirt. If I was an attendee, I would be jumping on that. So let's dive into our questions so far from attendees. First one, is there a way to prevent certain tables from being part of replication?
Yeah, I can take that. So behind the scenes, there's a feature called replication sets, and based on your application and what you do want to replicate around the cluster, you can either add tables or replication sets or hold them out. And kind of in the demo that I showed there, we kind of took the simple path of adding all tables to the replication set, but that can be configured for sure. And so one of the reasons that a customer might keep a table out of a replication set is actually to, for example, to keep PII data tied to a specific country or something along those lines. So there is a lot of flexibility behind the scenes, and we try to do the focus on making that case of replicating everything by default as easy as possible too.
Understood. Thanks, Curtis. Next question, what versions of PostgreSQL are supported with pgEdge?
Yeah, we focus on Postgres 15 and 16 primarily, and then we're working with a number of customers on Postgres 14 or below, potentially too. So you can just kind of reach out to us and let us know if you have specific needs on that front.
Yeah. If I could just add on to that, thank you, Curtis. So because we are 100% Postgres based, that allows us to keep up with both major and minor new releases of Postgres. So when Postgres 17 comes out later this year, you'll see pgEdge supporting that in a very short space of time, perhaps just a few weeks. And we'll probably be making it possible to use the early betas of PG17 as well.
Understood. Good to know. Our next question, how can we monitor replication and other metrics?
Yeah, I can take that. So you got a quick glance at what we expose in the UI currently. We've got CPU memory replication output showing there. So you can get a sense of the activity in the user interface. Behind the scenes, we support a lot of Prometheus-based metrics and monitoring. And we have we leverage a project called Vector, actually, to be able to push metrics to different destinations too. So you can push metrics for your pgEdge clusters to, say, AWS CloudWatch or other kind of cloud provider metric systems, or push them to, say, Datadog or whatever other metric system you have. So there's some configuration possible there to do what you need to do.
Understood. Next question, can you share more about how conflicts are handled?
Yeah. So by default, we take a last writer wins approach. In the event that there is a conflict, there's actually a Spock conflicts table where you can view all the detail about that. and then potentially your application can even take that into account and kind of choose a different winner if you wanted to do that. We're also going to be exposing this information in the user interface soon so that you can see it there. And this conflict information is actually queryable in SQL. So it's quite easy to monitor this and have metrics based on it too.
Thanks, Curtis. Another question that just came in. Do I need to use Cloudflare workers for my application code, or will pgEdge work with my current Postgres applications?
Yeah, I can take that, Curtis. Maybe you can chime in later. So while we enjoy demoing pgEdge Cloud with Cloudflare workers, you definitely don't need to be using Cloudflare workers. And in fact, again, because we are fully Postgres based, pgEdge will generally work out of the box with most existing Postgres application code and utilities. Of course, you are going to want to test that assertion, and in a few cases, we have, through our support, worked with customers to maybe make an adjustment to schemas to support replication. But for the most part, most existing applications will just run and tolerate the distributed model very well.
Understood. And Curtis, did you want to add anything to that?
The one thing I would add there is we actually have another Postgres extension which comes into play, which is called Snowflake sequences. You can take a look at that on our GitHub page too. But that's one of the other ways that we can accommodate applications, for example, that are using incrementing primary keys. Snowflake sequences helps accommodate those applications. So that's another fun Postgres extension that we offer.
Thanks, Curtis. It looks like we're through our attendee questions. One additional question from me. If there's one thing that you would really like our attendees today to walk away keeping in mind, what would that be? And Philip, why don't we start with you?
Sure. If you as an attendee are already a Postgres user and you've wondered about how it might be possible to support multiple regions with your Postgres applications, or how you address the latency issue, we'd love for you to just give pgEdge a try. And as we've shown, you can simply go to the pgEdge website and sign up and give it a spin yourself. And of course, reach out to us if you have any questions.
Thanks, Philip. And Curtis, anything you'd like to add?
Yeah, please give it a try. Once you log in to the pgEdge Cloud application, there's a link in there to the Discord community too that pgEdge has. So a lot of people are joining that, and that's a great way to kind of touch base with us, chat with our engineers about what you're up to, and get some really quick feedback. And we drop links in there to some of our GitHub projects and things like that too. So definitely check out our Discord channel.
Absolutely. Well, I would like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Philip Merrick, co-founder and CEO of pgEdge, and Curtis Misey, head of cloud engineering at pgEdge. So if you in attendance would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. This will be archived. It should be up on dbta.com tomorrow, and we will send everyone an email notification so you know when it's up. And once it is live in our library, if you would like a PDF of the deck, you can go to the handouts section to download that. Again, as I mentioned before, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on April 30th. We'll let you know if you're the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.
Thank you.